Welcome back, students. In this video, we're going to expand on our concept of specific heat to now talk about a very similar concept, very closely related, but different concept called heat capacity. Now, heat capacity and specific heat are very similar. Mathematically, they're very similar, but they mean slightly different things. So we want to make sure that you understand the difference between the two. First of all, heat capacity is represented as a capital letter C. And as it says here, specific heat and heat capacity are related but different. Specific heat, this is a reminder that specific heat is the amount of energy required to raise specifically 1 gram of a substance, 1 gram, 1 degree Celsius. And since the size of an individual degree Celsius is the same size as a Kelvin, it's also the energy required to raise specifically 1 gram of a substance, 1 Kelvin. In contrast, heat capacity, on the other hand, is the amount of energy required to raise the whole sample. Not just 1 gram of it, but the whole sample, not just 1 gram, by 1 degree Celsius. So the equation for heat capacity, therefore, is capital C for heat capacity equals the mass of the sample times its specific heat of that substance. Okay? So I'm going to draw your attention to the back of our periodic table. As you know, we have equations in the back of our periodic table. And look at this. We've got an equation for our calorimetry equation, Q equals mass times specific heat times delta T. And there's heat capacity equals mass times specific heat. In both of these equations, the lowercase m does not stand for meters. It stands for mass. Okay? So these equations and the variations are on the back of your periodic table. So just to reflect again, a specific heat of something, of a chemical substance, is the amount of energy that is required to raise specifically 1 gram, specifically 1 degree Celsius, right? Heat capacity, on the other hand, is the amount of energy required to raise the whole sample that you may have, regardless of its mass, by 1 degree Celsius. So I've got a very simple question here, sample problem A. What is the heat capacity of 7.00 grams of diamond? Now, why in the world you would want to be heating up diamonds, I don't know. What you do on your weekends is your business. But I've given you an example here. So remember what the equation says? The heat capacity equals the mass of the sample times its specific heat. So you may recall that in a previous section, I've given you a table with various specific heats here, right? So you have specific heats here. Notice what the specific heat for diamond is right there. Notice the units joules per gram degree Celsius. That's appropriate for specific heat. And with that in mind, go ahead and complete this problem. Pause the video to do so, and when you're done, resume the video and I'll work through this for you. So coming back from pausing the video and having done this work, we're going to calculate the heat capacity for a substance. We know that the general equation is heat capacity C equals the mass of the substance times its specific heat. So we're just going to plug in values. The mass is 7.00 grams times the specific heat of diamond, which was 0.502, and the units, of course, were joules of energy required per gram per degree Celsius for the specific heat, right? We check to make sure that our units of mass are the same so they can cancel, and they are. If I had given you kilograms of diamond up here in the problem, first of all, you'd be very wealthy, wouldn't you? But if you had kilograms up here, I would have engaged in a preliminary conversion to convert from kilograms to grams so that I could then plug that mass into my equation so that my mass units would cancel out, okay? We now plug that into our calculator and we get 3.514 rounded to 3 sig figs is 3.51 grams cancel, and look at the units, joules per degree Celsius. Now let's notice these units for a moment. This is the amount of energy required per degree Celsius, and that's the way specific heat should look. It's some amount of energy required to raise the whole sample by 1 degree Celsius. And so there is no mass unit left in these units for heat capacity because they have been canceled out. Okay? And there we go.